Okay, this will be the video for 3.2. Okay, so this video will be covering domain and range of different types of functions. So what we'll be looking at mostly in here is specific functions, and if you're given an equation, how to find a domain and range. So we've already talked about what domain and range are. So domain is the set of all x values or the inputs, and the range is the set of all y values or the outputs. Okay, so we'll start with this kind of thing here. And this is a linear function where you have the structure, the form of this is f of x equals mx plus b, you may recall. Y-intercept is the b, and the slope is the m right there. So actually this thing can be graphed without a calculator on this. So your y-intercept is -4, so you just make sure that you have a dot there at the point 0, -4. Your slope is 2. You can put that over 1. A slope is a measurement of a rise over a run, so it tells you go up 2 and then to the right 1. So from this point, I'll go up 2, right 1, up 2, right 1, and I like to just keep doing that as far as I can. You can also do this backwards. Down to left 1 is the same measurement essentially. So you end up getting, this is your line like this. So if we're looking at the domain, what can x be? Okay, well, you can multiply any number by 2, excuse me. Okay, so that means it can be any real number. And so if we wrote this domain in set builder notation, again, we use a set. We say set of x since it's a domain. And then we can just use this symbolism that x is any real number. In interval notation, that'll be -infinity to infinity. Okay, now when you're figuring out the range, you really got to look at your graph. What happens is, since x can be anything, and if you multiply a number by 2 and subtract 4 for different x values, you're going to end up getting anything. So you're going to get any real number. So the graph kind of shows you that it goes infinitely up and infinitely down. It goes through all y values. So this time we say set of y, such that y is any real number. And interval notation, we'll do exactly the same thing, -infinity to infinity. So when you're doing the range, a lot of times you have to look at a graph. Okay, number 2. Now this is something usually you'll learn a little bit about in college algebra. Before we graph this, let's just think about this. Basically, x could be anything because you can add 2 to any number, you can subtract 2, you can multiply numbers. So basically, x can be any real number again. So again, we just say set of x such that x is a real number. You use that double bar to represent that. And then in interval notation, you can say -infinity to infinity. Now this one I'm going to, pull up a graphing calculator here in a minute on this too, just to show you a couple things. But if you set this equal to 0, you're going to get what we call an x-intercept. An x-intercept is a point on the graph where the y value is equal to 0. If y is 0, you have to be on the x-axis. So this is already in a factored form, so you have x equals 0, x plus 2 equals 0, x minus 2 equals 0. That's a factored equation, so you end up getting x equals 0, so I'm going to put a dot there. I'm going to subtract 2 from both sides here to get x equals -2. Put a dot there. I'm going to add 2 here to get x equals 2. And then these are going to be the intercepts right there. Now, usually in college algebra, you learn different kinds of things about these functions and multiplicities and things like that. So kind of what happens on this is, since each of these things we call zeros has an odd exponent, they're all understood to be first powers, then it really means that the graph is going to cross through all of those points like that. And if you multiply this out, x times x times x is x to the third. You learn usually in college algebra that if you have a positive number in front of an odd degreed polynomial, that the graph does something like this. So that's what's going to happen on this problem is you're going to have something kind of swinging through these points kind of like this. I know that without my graphing calculator, but I'm going to pull that up just to kind of show you. Okay, so we get this a little bit more in depth. So your graph's going to look something like that, I promise you. So let me just pull up the graphing calculator and I'll show you what I'm talking about. Okay, so if I go through and put this in now, let me move some of this crap out of the way. Soulmate search of Okamore. What in the heck is that? Okay, I'm not looking for a soulmate, so I think I'll bypass that right now. Okay, so anyway, let's see. I need to kind of get this thing put together. This is a free online calculator, so I'm going to put this in, y equals, and I'll put x times x plus 2 times x minus 2. And an easy way to do a graphing calculator, you can press the zoom button, and then option 6 puts you in a standard window, so I like to use that a lot. And then that's kind of what that graph looks like. So this is a little bit more accurate than what we drew on here. But the point that I'm trying to make on this is that this will go through all y values. It's going to go infinitely down, infinitely up. So y can also be any real number. And it's good to kind of review these things that we call multiplicities. You may have learned something about that. So you can kind of know what the graph's going to look like without using a calculator. So now we'd have set of y such that y is a real number. And then interval notation, negative infinity to infinity. Okay, but you can use your graphing calculator to look at these graphs. Okay, so what I'm going to do now is we're going to look at specific types of functions. So we're going to start with the square root function. The thing you have to know here is the expression that's under a radical, whatever's under a square root symbol, it's got to be one of these things. It's either got to be a positive number or it's got to be 0. What it can't be is a negative, because then you'll get into an imaginary number. So square root of 4 is 2, square root of 0 is 0. But this is actually, the square root of negative 4 is not a real number, because you cannot find a number and multiply it by itself and ever get a negative number. Okay, if you multiply two negatives, you're going to get a positive, so the answer can't be negative 2. If you multiply two positives, you're going to get a positive. So again, you're never going to get negative 4 on that. So what you do, if you're going to find the domain of a square root function, you just take the expression under the radical and set it greater than or equal to 0. Okay, so you can sometimes do this in your head, but it's just always the same. Whatever's under the radical, set it greater than or equal to 0 and solve this inequality. And so you could subtract 6 from both sides, you get x greater than or equal to negative 6. So basically you can be negative 6 and bigger. And so in set builder notation, you just say set of x such that bar means such that, and then you write x is greater than or equal to negative 6. So that's how you write that. Interval notation, since you set that equal to 0, means you're including an endpoint, so you would say negative 6 to infinity like that. Okay. Now, what will happen on this one, if I went through and just made a table of values on this, what would end up happening is we would start at negative 6. So if we did negative 6 plus 6, we would get square root of 0, so that would be a point negative 6, 0. And then if you just pick some numbers bigger, like -5, you would have square root of -5 plus 6, which is square root of 1, so that's 1s. You'd have a point -5, 1, and so forth. So you could go through and pick numbers bigger than -6 and fill that out, or you can go to a graphing calculator, like I'm going to do, and you just put y equals, and you put in y equals square root x plus 6, go zoom 6. That's what your graph basically looks like. On a TI, you can get a table of values too that's real helpful to learn how to do if you don't know that. You just go second, graph, and then you'll have a table of values here. So you get a bunch of points. There's a point 3, 3. So we could use that point over 3 up 3 like that. And you can get as many points as you need to on this table of values. What you'll notice on this is once we get below -6, we're going to have nothing but errors because you're doing a square root of a negative number. So the other point I see on here is like -2, 2. So you can put that there, and then you got what your graph looks like. So looking at that now, if you have a square root, you're gonna the value of a square root is always 0 or bigger. So this one, what values can y be? It can be 0 or bigger. And you can tell that by the graph for the range. So you would have set of y such that y is greater than or equal to 0. Interval notation would be bracket 0 to infinity. Okay, so you're including that. So again, when you're figuring out the range, a lot of times it's useful to do a graph. Okay, next one, same thing, it's a square root function. So take what's under the radical, set it greater than or equal to 0, solve the equation. So subtract 4, you'll get -2x is greater than or equal to -4. Now we divide by -2 to get x by itself, so we get x is less than or equal to -2. So this can be -2 and smaller on here. And let me explain why you switch the inequality symbol. It's something you've learned before, but if you have something that's true, for instance, that 2 is less than 4, if I divide by a positive number, we'll notice that that is still true. But if I start over again and I divide by a negative number, like -2, look what happens. I get -1, I get -2. That's not true anymore. Actually, -1 is bigger than -2. So that's why you have to switch the sign when you divide by a negative. So this one, you would just basically say set of x, such that x is less than or equal to -2. Interval notation would be everything to the left of -2, so that would be -infinity, -2 at the bracket. And then again, we can make a table of values on this if we want to. And what I'm going to do is let's start with the -2 and just kind of work our way through that. So if I plug in -2, I would have square root of 4 minus 2 times -2. Like that, and I think I made a mistake here on this. That should be a +2 right there. Yeah, and I just caught my mistake by doing this. So if we plug in a +2 on this, it would go like this. We'd have 4 minus 2 times 2. That would be the square root of 4 minus 4. So if x is 2, you get a point 0. And then you would have to choose numbers smaller than 2, like 1. So if you did square root of 4 minus 2 times 1, you end up getting square root of 2, and so forth. And square root of 2 is about 1.4. So if I put this in the graphing calculator, this is basically going to kind of look like this. Go y equals square root 4 minus 2x. That's what your graph basically looks like. Again, you can use your table of values. You can go second graph, And then you can get as many points as you want to this way. So there's a point -6.4. There's a point, I see a point 0.2. I see a point -6.4. You can use as many points as you want to. So this graph basically looks something like that. Okay, so again, y can be 0 and bigger. Set builder, we're going to say set of y such that y is greater than or equal to 0. Interval notation will be bracket 0 to infinity because we include the 0 like that. So if you're dealing with a square root function, so if you're working with a square root function, just domain's real easy. Just set what's underneath the radical greater than or equal to 0. Okay, next thing we'll look at is functions that have variables in the denominator. So what will happen on this is typically you have to figure out what makes a denominator 0. Okay, so you can't divide by 0. If you ever forget that, I saw somebody do this one time. It's just think of the word no. If you take any number divided by 0, then no, you can't divide. Okay, so you can't divide by 0. So what we're going to do is we're going to figure out what makes that denominator 0 by solving this equation. And we get 3x equals -2, then divide by 3. So x can really be any real number except -2/3. So it can't be that. So you can actually write this like this. You could say set of x such that x is a real number, and then just put a comma, and you could say x cannot equal -2/3. Okay, and actually, if you just write it as set of x such that x is not equal to -2/3, that's okay. That implies that it's any real number. So now you have to break it up into two intervals. You have to say everything less than -2/3 and everything greater than -2/3. So you're just saying it's everything else on the number line. So you may have learned a little bit of this in college algebra. This is called a vertical asymptote. And I'm not going to get into a lot of the specifics on that. But if you go to -2/3, the graph will not cross that asymptote. It'll just kiss it. Okay, kind of kisses the asymptote. That sounds funny. All right, so that's how that goes. Now, as far as your range, you really need to look at your graphing calculator on this. So I'm going to pull up the calculator and we'll put this in. And this kind of goes like this. Okay, I'll put in parentheses. You have to have a numerator in parentheses. You have to have denominator in parentheses. Like that. And then you can go zoom 6. And that's roughly what your graph looks like. This thing also has what we call a horizontal asymptote. And that horizontal asymptote is going to be at 1/3. We're going to review that kind of stuff a little bit more in depth, but the idea is if x gets infinitely big, then the 2's don't really matter. It's not that they cancel, it's just if x gets infinitely big, all it really matters is the x divided by 3x, so you get 1/3. So what happens is x gets big, infinitely big, the graph gets close to 1/3. So if you look at this graph on here, you're going to see that it kind of approaches 1/3 from both sides, and it's just sort of a rough graph on here without a lot of detail on this. This graph's going to look something kind of like this. It gets close to the asymptotes, but it never reaches the asymptote. It just gets close to it. Like I say, it's like kissing the asymptote. Okay, so it goes like that. So what can y be? Well, y can be any real except for 1/3. So we would write the range as the set of y such that y is not equal to 1/3. And you could also add in the real number, but you can do it that way too. And then it would just be interval would be everything except 1/3. So you just write that in interval notation like that. So you really need the graphing calculator to help you with the range unless you're really, really solid with how this type of graph goes from your background. Okay. Next problem. What I'm going to do is I'm going to factor the denominator. Okay, so again, what we're looking for on this, the first term is x squared, so that's got to be x and x. The last term is 18. So you're looking for numbers that multiply to give 18, that also add up to -3. And the correct choice is that 3 and 6 can be made to add up to -3. So you put a 3 and a 6 there, minus and a plus there. Now, in this problem, if you're finding the domain, don't cross out the x plus 3. Just leave it alone. The thing is, if x is -3, that makes this 0. And if x is equal to 6, it makes that factor 0. So x can be any real number except it can't be -3 and it can't be 6. Okay, now you're going to have an asymptote and then you're going to have what we call a hole. And I'll kind of talk a little bit about how that goes because you may have learned a little bit more about that in college algebra. So the domain, we'll say set of x. We could say x is a real number, or you can leave that out. Then you can just say x is not equal to -3, 6. Interval notation, you have to do 3 intervals. You have to say everything to the left of -3, everything between -3 and 6, and then everything to the right of 6. So that's how that goes. So what you'll find on this is if something cancels out, it gives you what's called a hole. The one that's left over is going to give you what you call a vertical asymptote. And it's really beyond the scope of this section to really dive into the details of what asymptotes are. I can give you a little bit of an idea. But the idea is when you have a vertical asymptote, as the graph gets close to the asymptote, then it either tends to get infinitely big or infinitely small. Okay, and then over at -3, you're going to have a hole. This one will also have a horizontal asymptote at y equals 0. Okay, now I'm going to pull up the calculator on this. And we'll go ahead and put this one in now. Okay, so put in the original. So if we put in parentheses x plus 3 divided by, and then if I put in x squared minus 3x minus 18, and just put that in. Notice I'm using parentheses. Go zoom 6. That'll give you roughly what this graph looks like. Okay, so what's going to happen on this, I'll show you a couple things. We can go to our table and we can get a couple of good points if we can find any. Most all the points on here are just going to be decimals and stuff. See, there's an error at -3 where there's a hole, and then there's an error there. So I see a couple of points on here. I see 5, -1. And I also saw 7, 1 on there like that. So this graph kind of does this. As it gets close to the asymptote, it's going to go to infinity. It's going to get close to the x-axis. It's going to go down kind of like this. And then what's going to happen here is if you cancel this out, you'll get 1 over x minus 6. And if you replace that with -3, you're going to get 1 over -3 minus 6, which is 1 over -9. So when you're at -3, the y value is around -1/9, but there's a hole there. Okay, that's the way the graphing calculator doesn't show that hole. So that's how that looks. Now, the purpose of us doing this is to see Well, does y, since we have a horizontal asymptote, it never crosses the x-axis, so y can be any real except 0. So set builder, we'd say set of y's such that y is a real number, or you can leave that off and then just say y is not equal to 0. Interval notation, everything below 0, everything above 0. Okay. So that you want to be able to do the domain without relying on your calculator. In these problems, really all you're looking at is what makes the denominator 0, and use your calculator to kind of help you figure out the range. Okay. So we'll go to the next page, and I've got 3 problems that I want you all to try to do. And pause the video so you can work on these on your own, because you'll learn more that way than if you just keep copying. So pause your video, and then when you're ready to check your work, just resume. Okay, so you go ahead and check what you did on this. The first one, take what's under the radical, set it greater than or equal to 0, solve the inequality. So you end up getting x less than or equal to 2. If you put this in the graphing calculator, you're going to get a graph, and it'll show that x has to be less than 2. There's no graph to the right of 2. And then the graphing calculator is going to show you that the graph is always below the x-axis, but it does hit the x-axis at 2, so your range is going to be anything less than or equal to 0. And the reason for that is because there's a negative in front of the radical, which causes it to reflect. Okay. Number 2, you would have had to factor the denominator. You don't have to factor the numerator, but you could. And this problem right here, I think, has some things that you could not really figure out on the range unless you knew something about calculus. So it's not a good problem to give a pre-calculus student. So anyway, the domain is anything except 4 and 5. You have 2 vertical asymptotes. So you can see how I wrote the domain. Now, the thing is, it looks like y is going to hit every number. So I just left that off. I mean, it looks like it goes below the x-axis and everything, but it never gets down to infinity. So if you were a calculus student, you would have a way to figure out what this minimum is, and that would help you figure out what the range is. But we can't do that in this class. There's no way to do that. I probably could go through and show you this on the graphing calculator, and this is probably worth doing. So let me show you what you could do on this. So if I put in, if I graph 2x minus 4 in the numerator, divide by x squared minus 9x plus 20. And if I do this in a standard window, you've kind of got a minimum right there. But now the graphing calculator will figure that out for you. I'll show you how to do that. So if you go second trace, there's a minimum feature on this. And what you have to do is you have to get your cursor so that you know you're to the left of that minimum. So I can tell I'm to the left of that minimum. I press enter. For a right bound, I just need to move over to a point where I know I'm to the right. When it says guess, I just move my cursor right to where it looks like that minimum is, and then it'll figure it out for you. So actually, that minimum is about negative 0.202041. So technically, this problem could be written like this. You could say, in interval notation, it looks like it would be around negative 0.202 and then to infinity, like that. That's what it looks like on my graphing calculator. So it looks like it goes through every point on there, except it won't be less than that number, negative 0.202. Okay. And I guess in set builder, you could say set of y such that y is greater than or equal to negative 0.202. This problem's not really all that important, for a student in this level of a class. Okay, number 3 is it's a parabola, so x can be anything. You can square any number, so there's no problem with x. But you have to know how the graph looks in order to figure out the range. So if you graph this using a calculator, if you wanted to, and just getting some values, you would find that you do have this point 1, 0 on the parabola, but then all of the y values will be above that. So your range would be bracket 0 to infinity. Okay, all right, so we'll move to the next page. Okay, so the next thing is we're going to look at a graph and figure out the domain from the graph. So the domain is the x value, so it's a measurement of this way. And since this has a solid dot, that means that graph ends there. If there's not a dot, assume that it goes on forever. So x looks like it can start at -5 and then just go on forever. So it looks like -5 and bigger is what your x values can be. So domain can be written set of x such that x is greater than or equal to -5. It does include -5 because there's a solid dot there. And then your interval notation would be written like that. The range is this way, so it does look like you have a lowest value of y, and that lowest y value is -4. So it looks like y can be -4 and bigger, according to the graph, because it goes on forever. So we would say set of y such that y is greater than or equal to -4. Interval notation, we say bracket -4 to infinity, is how that would get put together. Okay, so x is just a measurement of left and right, y is a measurement of up and down. So on this one, it looks like x is going from -2 to 2. It's going from there to there, but that's a hole there. So basically you're going to be between -2 and 2, but you're going to include the 2 because there's a solid dot there, but you're going to exclude the -2. So in the way you write this in set builders, you say set of x, then you say -2 is less than x is less than or equal to 2. So what that does is this is the way of saying include. Less than says exclude. Okay, so that's how that would go. Interval notation would be parenthesis to exclude and bracket to include. So that's how that would go. So now if you look at your y values are this way. It looks like this is your lowest y. And that right there looks like that is your highest y. That is a solid dot, so that's a definite point. So it looks like it's going from -6 to 3, it looks like. So it looks like this is going to be between -6 and 3, including both of those. So if you wrote this, you would say set of y such that -6 is less than or equal to y. That's how you include, and then less than or equal to 3, so you would include like that. And including in interval notation just means you use brackets. Okay, so that's how that would go. Okay, let's see, this one kind of interesting. Okay, you have an asymptote on this. So the domain is all of these x values except it'll never reach 2. So the x value on this can be any real number except 2. So set builder, we just say set of x. X is any real number, and x cannot be equal to 2. Intervals, you just say everything to the left of 2, union everything to the right of 2, like that. Range is the same way. You have a horizontal asymptote, so you're never going to touch y equals 0. You'll never reach the x-axis. So this would just be any real except 0. And then set builder, we say set of y. Y is any real number, but y cannot be equal to 0. Interval notation is everything below 0 and everything above. Okay, so that's how that gets put together. Okay, next one's kind of an interesting one. It's just a horizontal line. Well, x can be any real number. Okay, it's going forever to the right, forever to the left, no holes or anything in this, so we just say set of x. X is any real number. Interval notation, negative infinity to infinity. Y can only be, see, look at my pen, it's sprung a leak. How can that happen? Okay, so we got that. All right, and I'm checking my fingers to see if there's ink on it. Okay, range. Set builder, now what's weird on this, you just say set of y such that y is equal to c. Okay, interval notation's weird. You just say bracket c comma c. You have to use brackets to include the c, so that's how that goes. Okay, so that gives you kind of an idea. We'll go to the next page and let you try these problems. So if you'll pause the video and then resume when you're ready to check to see if you got these okay. Okay, so let's kind of see if you got the first two here. Okay, so I'm just saying that x can be less than 0 or greater than 0. That one's a little hard to tell. It looks like it's not going to the y-axis, so you may have had a little trouble figuring that out. That's just is not a great graph, but that was the intention on that. So set builder, you just say x is less than 0, x is greater than 0. It can't be equal to 0, so it's that way. Interval notation that way. Y has to be greater than 0. That's pretty easy to tell on the graph. So here's your range in set builder and interval notation. B looks like x is 15 and smaller. So here's how you'd write the domain. And then the y value, it just keeps getting bigger and smaller. So y is going to go through everything. So that would be any real number. Okay, pause the video if you need to correct anything. Okay, going down to these next two here. And did I number all the rest of these B? Okay. Okay, nutty professor. Okay, so this one is x can be less than 2, or it can be greater than or equal to 3. Okay, so because you have a solid dot there. Okay, less than 2 because you have an open there. Okay, so all of these x values less than, it would be how you write the domain. Notice you have a bracket on the 3 to include that, and a parenthesis on the 2 to exclude that. As far as your range goes, this is the lowest value of y is -8, and it just keeps getting bigger. Okay, this thing right here doesn't have any bearing on anything because you hit that y value there and you hit it over there. So that doesn't have any bearing on the problem at all. On the range, it does have a bearing on the domain, though. Okay, and then the last one, kind of the same idea. Even that on the domain, it doesn't make any difference because x is equal to 1 down here. Same thing here. At x equals 2, you do take on a value. So it's going through all real numbers. And it kind of works the same thing on the range. This number right here, where this bubble is, well, you've already got that defined right there. And where this bubble is, that's defined over there. So the range is 0 and bigger. Okay, so I'll move the next page. Functions. Okay, now this is an area that students struggle mightily with, and I never have been able to figure out why. The best way to do a piecewise function, and this just means you have 2 or more pieces in your function defined on different intervals. The best way to do it is to do tables of values. Okay, and I'll kind of go through and show you how to do this. So the key on this is your very first function square root of x. The thing is, this tells you what kind of numbers to use for x. So you can use 0 and bigger. And just pick some numbers that are bigger, but also pick numbers you know square roots of. You could pick 2 if you wanted to, but I'd rather pick 4 and I'd rather pick 9. And then I'd just do square root of 0 and so forth. Like that. Square root of 2 is like 1.4 and so forth. Okay, and since that has an equal to bar, that means that this is included. So if I graph these points, I need to make sure that that's a solid dot there. And then I can plot these points. And then this graph just goes to the right. The idea is if x is greater than or equal to 0, then you've got this graph right here. So it doesn't go on forever in both directions. Okay, the next one, you've got absolute value of x, but it says that you can only use x is less than 0. Now you do want to use 0, but you want to make a note to yourself that you're excluding that point. But you do want to use 0 because the graph comes to an end at 0. Then use numbers smaller than 0. And then just take their absolute value. And you can do all this in your head. Okay, graph the points, 0, 0. Notice that it connected. So you have the same point. You're not going to put a bubble over that because it's already solid. And then you just go through and graph the rest of the points. So that piecewise function looks like that. One thing that you want to do is you want to do the vertical line test every time you do a piecewise function to make sure it's a function. Because the biggest mistake students make a lot of times is they say, okay, it's an absolute value, so it goes both ways. No, it doesn't, because it says x has to be less than 0. And if you made it go both ways, it wouldn't even be a function. Okay, so pay attention to that. When you get this done, make sure that it's that you're actually graphing a function. Okay, so a couple of mistakes students make on that is they want to draw the graphs in both directions. Can't make that mistake. The other thing is use the 0 for both table of values, even though one of them is included and one's excluded. Still use it because that's where the graphs come to an end. Okay. Next one would be done the same way. So we start with this. So we'll have y equals x plus 2. Now, we can only pick 2 and bigger. Now, we are going to start with 2, but when we graph that, we're going to use an open bubble to represent where that comes to an end. Now just pick numbers bigger than 2. Okay, plug it into the function. 2 plus 2 is 4. 3 plus 2 is 5, and then 6, 7, and 8. Okay. Now when you plot your points, go to 2 and 4 and put a bubble there, because that's where the graph comes to an end, and then you've got 3, 5, and then you got the rest of your points going like that. And again, notice I only go to the right because if x is greater than 2, that's where that graph is. It does not go to the left. Okay, so don't make that mistake. Second part, we're going to graph y equals x the second minus 2. So use 2. Make a note to yourself to include that. Then pick numbers smaller than 2, like 1, 0, -1, -2, and so forth. Plug it in and calculate carefully. And then you'll get your numbers here. Now, when you get down to -1, if you do -1 squared minus 2, that'll give -1. If you go to -2 squared minus 2, that's 4 minus 2, so that's 2. So your second graph, you would have a point 2, 2 with a solid dot, and then the rest of these points, just plot these. And then again, notice that I'm only drawing that to the left because this says x is less than or equal to 2. The graph does not go on forever in both directions. Make sure that this is a function. Make sure it passes the vertical line test. Even right there, it's only going through one point. You're never going to have two solid dots because then it's not a function. Okay, passes the vertical line test. Okay, I'm going to do one more. Here's one with 3. So this one just has 3 pieces to it. So the first one, we're going to graph out y equals x squared. We're going to use 1 and smaller. We're going to include the 1. Now just pick numbers smaller than 1, like 0, -1, -2, -3. Square these numbers like this. So you're going to get your first piece. So we're going to plot the point 1, 1 with a solid dot. 0, 0, everything is solid. -1, 1, -2, 4, -3, 9. And again, this graph only goes to the left because the graph said that x is less than or equal to 1. So it does not, when x is bigger than 1, it's not, you're not graphing that x squared, you're graphing something else. Okay, the next piece is a straight line. And this goes like this. You'd have an open there. And that just means you have a point 1, 3, because y is always going to be 3. So you go 1, 3, and you put an open bubble there. Then you go to 2, and you're going to have the point 2, 3, and that's going to be closed. And all that's going to be is just a horizontal line. Okay, then the last piece would be this part right here, which is y equals x. We're going to use 2 and bigger. Again, use 2, but just make sure that it's open. And then pick numbers bigger. Okay, if y is equal to x, then x and y are the same number. So that plot these points, you'll have 2, 2 that will be open. And then 3, 3, and so forth like that. So that graph goes on like that. So again, this graph here is when x is greater than 2. So you have 3 distinct graphs. Okay, do not make the lines go both ways. I don't know why students do that, but they do it all the time. Do what the problem tells you to do. Follow the directions. Obey the law. Okay, then all will be cool. Okay, work these 2 out. And then just pause your video and I'll put the answers up to the next 2. Okay, so you can kind of look and see what you have here. Here's what your graphs look like. So you want to make sure you filled out table of values exactly like this. Notice that this one is open and you had to start with -1. If you didn't do that, you did that wrong. And then this one is closed. So then you're just using numbers. On this first table of values, use numbers -1 and smaller. Second one, use -1 and bigger. Calculate, plot points. When you get right down to it, it's doing arithmetic and plotting points. Really, okay? That's what it is, okay? You don't make it any more complicated than what it is. Okay, so the next one, and you can pause if you need to pause the video right now to correct things. Number 2 looks like this. You have 3 pieces. So the first piece is, again, open on the -1. Notice that I used -1 and I made sure that I was using an open bubble there. The one in the middle is just y equals -3. So I had your closing on the 1 and you're open on the 2. So notice that this kind of represented the less than, and that right there represented the less than or equal to on that part of the graph. And then 2 and bigger on the square root, but make sure that that less than or equal tells you that that is closed. So that's how the graph would go. Do your table of values, do your calculating. Again, it's plotting points and doing arithmetic. Okay, last page on here. This is just kind of doing this backwards. So in math, you want to be able to do things forward and backwards. So there's actually three pieces of this function. And what they are is this graph is y equals 5. This graph is y equals -6. And this graph is y equals 3. Okay, and that just means that y is always 5. That's what makes it a horizontal line. Every point on that line has a y value of 5. So we just say 5, 6, or -6, and 3. And do it from left to right. So this interval here would be when x is less than or equal to 0. Okay, and the reason it's less than or equal to is because that is closed. Okay, now the next one, you're going to be between 0 and 4. So you're going to be open and closed. So you say 0 to 4. You exclude the 0. You include the 4. Okay, so think about how those things match up. See? Open, closed. Okay, and then the last one would just be 4 and bigger. So you would just say x is greater than 4. And again, pay attention to that being open. Okay? All right, so pause the video, do the next problem, and then that'll wrap this up. Okay, so there's your answer on that. Just see if you got that right. You have y equals -2 when x is less than 2, y equals 3 between 2 and 6, include both. That's why I have the less than or equal to. And then y equals 0 when x is greater than 6. Okay. Hope that helps you study the piecewise functions and don't mess up on them.